All right, so number 12, got a lot going on here. It says that the function f is a given function. It says that letter g comes from the table, and it says that letter h function comes from the graph. So we got three separate functions all going on at the same time here, just so we can process each question. F of x comes from the box, g comes from the table, and h comes from the graph. So letter A says find the slope of the tangent line to the graph of f at x equals pi. So that's asking us to do f prime of pi. So I want to first find out what f prime of x is, and we can derive that. It should be the derivative of cosine is negative sine 2x, and then chain rule the 2. And then we go plus e to the sine of x, and we chain rule the power, which is cosine of x. So if I plug in pi, f prime of pi, it would be negative 2, right? 2 over here. And I would have sine of 2 pi. And then I would add e to the sine of pi times cosine of pi. Let's take care of those pieces. So sine of 2 pi is 0. So all this right here is 0. E to the sine of pi, again, the sine of pi is 0, so e to the 0 is 1. And then cosine of pi is negative 1. So the answer to A is negative 1. The slope at f, so the tangent slope at pi for f is negative 1. Next one. Wordy. Let k be the function so that k of x is equal to h of f of x. Remember, h is the graph, f is the function. It wants us to find k prime. So let's talk about how to write this in differentiated form. We'd have to use the chain rule. So k prime of x is equal to h prime of f of x. And then we would chain rule, so times f prime of x. So if we plug in the values there, k prime of pi is actually equal to h prime of f of pi times f prime of pi. Ooh, it's a lot to handle. Let's go piece by piece. Let's start with f of pi. So I have h prime of, let's get f of pi. Let's go back up to the top. So f of pi is equal to cosine of 2 pi plus e to the sine of pi. Cosine of 2 pi is 1 plus e to the sine of pi is 1. So this is 2. That's f of pi. Times f prime of pi, we figured out in the last example, that's negative 1. So what I need to do is determine the slope at x equals 2 on the graph. So h prime is the slope of h at 2, and then multiply it by negative 1. So if I go back up to the graph and go to 2, I need to find the slope at this point. Well, if you look at it, it's actually 1/3, negative 1/3. So that means that h prime of 2 is equal to negative 1/3, right? So if I go down here, I'm going to change all this right here to negative 1/3, but then I'm going to bring back that negative 1, and so my answer to the second one here is positive 1/3. All right, last but not least, looks like I have an inverse. It says that m, or another one, m is the inverse of g. So m is inverse of g. So how does that work? Well, it says here to write an equation of a tangent line for the inverse at x equals 2. So I need to find m prime of 2. I want to point out that if m is the inverse, then if m is the inverse, this input for 2 has to match with an output. And again, for g, that means that that 2 would actually become the output. So my first task is to find what number goes right here for g. Well, if I go up to the table, if 2 is the output, that marries me up with -3. So I know that this is -3. I know that this is -3. And so my first task is complete. So I know that m of 2 is equal to -3. So step 2 would be to find g prime of -3. So take this value and plug it into the normal. So remember, the normal is g. So the inverse of g is m. So if I go back up here and go g prime of -3, end up with 4. So this is 4. And then step 3 would take the reciprocal of that, which is 1/4. So this is the slope for the inverse function of g at this point. And so my last task would be to write an mx plus b form. I'm actually going to write it in point slope. But it'd be y plus 3 equals 1/4 x minus 2. This is my equation.